Hello guys, how are you? Today we will be working on grade 10 physical science. Now, today our topic will be electricity. Shocking, right? It's just a dad joke, guys. Now, we will be dealing with parallel circuits and series circuits. Don't be afraid, guys. Parallel only means that the components are connected in a separate loop or different branches or next to each other, okay, in different wires, okay. And then the series circuit means components that are connected in a single line, one after the other, okay. So before we start getting into the differences of how the current and the voltage work, let's actually talk about what measures current and what measures voltage, right? So let's look at our circuits. What we have here is a voltmeter, okay, and this is known as an amp meter. Although it's not displayed here, we can still calculate our current. Then what we also have is this. These are called resistors, okay. And what we also have, we have this, which is the battery, and then we also have the switch. Now, one by one, I want us to go down the list and view all of these, right? So starting off, oh look, I had searched for a battery. So guys, this is what a battery looks like in a circuit. Yeah, this is just a battery, not in a circuit, but this is just a battery, what a battery looks like. Now we're going to look for the amp meter. I like it when students get to realize that some of the things that we're talking about are not one thing, they are not connected to the system. We use this equipment to construct proper circuits and also to find faults in our circuits, and it helps us diagnose and create new systems. So this is an amp meter, guys. It calculates current, okay. Now we're going to look for our voltmeter. Okay, so this is a voltmeter, guys, right? It's normally connected next to the component that is drawing energy or that is drawing voltage, in order for us to figure out how much voltage is being used at that specific point. We use this voltmeter. And now let's look for a switch, just for the fun of it. Oh, not the switch. Let's look for a light switch, guys. So this is the switch that we have over there. This is the switch. It can be any kind of switch, okay. Okay, guys, and what is a resistor? So basically a resistor, so this is that, but a resistor, most of the time you will find this in a device. So you'll find this little resistor in a device, and the device can be your laptop, it can be the TV, it can be your charger, it can be anything, right? So these resistors are representing items like microwaves, light bulbs, and such, right? So anything that plugs into the wall causes resistance, right? Because it disturbs the flow of current, or the flow of current, it disturbs that, right? So therefore, yeah, resistor. So now let's look at these two guys. So we're going to look at how current behaves in two of these. So now the current is the same through every component. When we are talking about current is measured in amps, right? Amperes, right? So whenever we have a circuit that is in series, current will always remain the same, right? So if we have maybe 2 amps, I'm so sorry, I can't write properly, 2 amps, that 2 amps will be the same throughout for this resistor, and for this resistor. It will never change. So we're not yet calculating anything, but if we were calculating B I R, if we were calculating for every one of these, we would use 5 as the resistor, but then I would, for my current, I would use 2. If I was looking for voltage for the third resistor, I would use 7, but then my current, I would use 2. So therefore, when we are talking about current passing through this system, it does not change. But wait, when we are talking about current in this system, something happens. When the current reaches here, it splits accordingly to how much is required in each branch, right? So in this parallel circuit, the total current from the source splits and flows through each branch. The current through each branch is not necessarily the same. So if we had over here 5 amps as our current, and it was flowing coming here, it could decide to move 4 to the side and 1 over here. So what we know is that when you combine, even if there was a third branch over here, if you combine all the currents in all the different lanes under a parallel circuit, it will give you the complete current. Let me repeat that. If you add all the currents that you find in all the different lines in a parallel circuit, it will give you the original current which is found throughout the circuit connected in series. And listen to me, because okay, let's do this now. Because this is a parallel connection, but from here to all the way over here to this side, it's a series connection. A1 and A4 are in a series connection. They are not parallel to each other. The wiring that comes through here passes through all here and then comes through is the same. So the current at 5A is the same as 4A, but the current at A1 will be A2 plus A3. Okay, but A1 is the equivalent of A4 because these are connected in series, whereas these are connected parallelly. Now let's talk about the voltage. Now the voltage in a series circuit, the total voltage is the sum of the voltages across each component. In a series connection, voltages will differ. For us to find how much our battery voltage has, we would have to plus V1 plus V2 plus V3. This would vary. In a series connection, these vary. They vary. Okay? Now, let's move to this side. In a parallel connection, something interesting is happening over here. Now remember, what is voltage? Voltage is the pressure, right? Is what builds the pressure to be able to move the current, right? It's the push. Okay? Now, what happens, there's something interesting that happens over here. You see, when current comes into a parallel connection, it will split unevenly. But voltage does something differently. It splits evenly. You see, in the series connection, it is the current that will move evenly through all our components. But in the parallel circuit, something magical happens. The voltage is the same across every component. If one component fails, the other component can still operate because the current can continue to flow through the other path, right? So let's look at this. If voltage here is 2V, it's coming down, and then it reaches here. Let's use our pen. Just gonna pick a nice color for voltage. I'm just gonna do a red. So we're gonna have our voltage going and then it's gonna get here. It's gonna say, am I gonna split? And it's gonna say, no, I'm not gonna split. I'm gonna go 2 volts all the way and push that current, however much current there is, and I'm gonna go 2 volts down, baby. We're gonna push, right? And listen to me, V1 will be 2V and V2 will be 2V. Okay? So in a series like this, when something has parallel and there's no other connection over here, the voltage will remain the same in these paths. In line 1 and line 2, you will have 2 volts passing through each one. 2 volts, right? Because that is the pressure pushing the current. All right. I think we have it here a little bit summarized. This is the fundamental difference in the behavior of current and voltage in a series and parallel circuit is summarized below. In a series circuit, the current stays the same through all the components. So I total is equals to I1, I2, or I3. Remember, guys, like I said to you? Okay, and in a parallel circuit, I1 plus I2 plus I3 is equals to I total. I total being the initial current that is found in the system. Okay, now we have voltage. They say voltage divides across the components in series. So the V total in series would be V1 plus V2 plus V3. Right, but in the parallel, the voltage is the same across all components for the branches. So V total, it can either will be equal to V1 or it will be equal to V2 or V3. Okay, now the sum of the individual resistance, there it is in a total resistor. We go R1 plus R2 plus R3, and with the total resistance in a parallel circuit, we go 1 over our total, 1 over, you see that? But now I will show you how we work out those calculations at the end. Yeah? Okay, so guys, this is another example of a series and parallel circuit. So this is a series and this is a parallel circuit. If I cut off this line over here, this will still switch on. But if I cut this line over here, both of them will switch off. Okay, so we have one last thing I wanted to talk about. It's Ohm's law. Ohm's law. So the Ohm's law describes the relationship between current, potential difference, which is also known as voltage, and resistance in a circuit, specifically for an ohmic conductor where resistance is constant. It states that the current flowing through a conductor between 2 points is directly proportional to the voltage across the 2 points and inversely proportional to the resistance between them. So what this is saying in basic English is that voltage and the resistance and current have a relationship where when you have two, they can predict the other. They are the equivalent of each other, right? In not directly though, right? Inversely, proportionally, directly, proportionally, right? Okay, it's fine. So what this looks like brings us to something like this. When we are looking for the voltage, we will use our current to multiply by our resistor. When we are looking for our current, we will divide our voltage by the resistance. And when we are looking for the resistance, we will divide the voltage by the current. Thank you very much. On the next episode, we will be diving into calculations.